This is lesson 13.9, permutations and combinations. An arrangement or listing in which order is important is called a permutation. We can use the fundamental counting principle to find the number of possible permutations. So when it says that order is important, an example of that would be your class schedule, for example. There's a difference between math then English versus English then math. So the order there is important. You're not just selecting classes, you're selecting classes in a particular order. The notation P and then in parentheses 6 comma 4 represents the number of permutations of 6 things taken 4 at a time. So in our class schedule example, this would be the number of class schedules possible of 4 classes with 6 to choose from. So you have 6 classes to choose from and you have to choose 4. And it can be calculated as follows. Well, we start with the first of the 4 things that you need to choose, and you have 6 choices to choose from. And then once that first one's been chosen, you only have 5 left to choose for the second one. Once that one's chosen, you have 4 left to choose for the third one, and then only 3 choices left for the fourth one. And we don't keep going because we're only choosing 4 things. 1, 2, 3, 4. And if we multiply this out, 6 times 5 times 4 times 3 is 360. Okay, so let's take a look at example 1. How many ways can the top 5 finishers be arranged in a 20-person cross-country race? Well, the notation here, we're looking for a permutation since the order matters here. Difference between first place, second place, third place. Obviously, there's an order to that. So we want a permutation. We have 20 people to choose from, and we're going to choose 5 of them. Okay, so we have 20 people to choose from. So for the first place person, we can choose 20 people. For the next place, since that first person's already been chosen, we only have 19 possible options. And then for third place, 18. For fourth place, 17. And for fifth place, 16. So starting with 20, 1, 2, 3, 4, 5. And when we multiply all of these together, we get a whole lot of different orderings. You end up with 1,860,480. Okay, and for the second example, how many 3-digit locker combinations can be made from the numbers 0 through 30 if each number is used only once? So in this case, it's a combination, so it has to be in a certain order because, for example, if you're putting in a combination into a locker, there's a difference between 5, 13, 24 and 13, 24, 5. So the locker combination does have to be in a particular order. So this is also a permutation. We have not 30 numbers, but 31 to choose from because the number 0 is also included. So 31, and it's 3 digits, so we're choosing 3. Okay, so for the first digit, we have 31 options. For the second digit, because one has already been chosen, we have 30, because each number is used only once. And then for the next one, we have 29. And then when we multiply these, we get 26,970 possible combinations. Okay, so there's 2 try it yourself problems at the bottom of the page for you to do on your own. Go ahead and pause the video and work through those 2 problems, and when you're ready to check your answer, press play. Okay, for this first one, you should have gotten 840. And for the last one, I should have gotten 720. Okay, so those are permutations. Next, we're going to talk about combinations. So sometimes order is not important. A combination is an arrangement or listing in which order is not important. We can find the number of combinations of items by dividing the number of permutations of the set by the number of ways each smaller set can be arranged. So an example, a combination would be something like choosing a group for a group project. It doesn't matter what order those people are chosen in. So if you choose Sally and Susan to be in the same group, it's the same as choosing Susan and Sally to be in the same group. The order does not matter. You're just choosing a group of things. So the notation C, and then in parentheses 6, 4, represents the number of combinations of 6 things taken 4 at a time. So 6 to choose from, and you're going to choose 4 of them. And it can be calculated as follows. Well, it would be calculated at first the same way as the permutation. So 6 ways to choose the first thing, 5 ways to choose the second, 4 ways to choose the third, and 3 ways to choose the fourth. However, this would include combinations that are essentially the same, because if the order doesn't matter, like I said, something like Sally and Susan is the same as Susan and Sally. So we actually need to divide this number by the number of ways to arrange each of those sets. So let's say we had a set of 4 things and we had to figure out how many ways to rearrange that. Well, basically that is just a permutation of 4 things taken 4 at a time, because you're taking all 4 of them and reordering them. So we have 4 ways to, or 4 things to choose for the first one, 3 things for the second one, 2 options for the third, and just 1 option because there's the only one left. Okay, so 6 times 5 times 4 times 3 is 360. 4 times 3 times 2 times 1 is 24. And when we divide those, we get a total of 15 combinations. Okay. So example 3 says, how many different sandwiches can be made with 2 types of cheese if the choices are cheddar, Swiss, American, pepper jack, and provolone? Well, if you think about it, the order of the cheese doesn't matter. A sandwich made with cheddar and provolone is the same as a sandwich made with provolone and cheddar. So it doesn't matter. So this would be a combination, and we have 1, 2, 3, 4, 5 cheeses to choose from, and we're going to choose 2. Okay, so we'll start off just like we would for a permutation. So we have 5 choices for the first cheese and 4 choices for the second, and we're only choosing 2, so we stop there. Well, to take care of the ordering, because the ordering doesn't matter, we divide by 2 choices for the first one, 1 choice for the second one. And up here, 5 times 4 is 20. In the denominator, 2 times 1 is 2. So when we divide these, 20 divided by 2 is 10. So there are 10 different types of sandwiches that can be made. Okay. And example 4 says, in a science class with 42 students, how many 3-person lab teams can be formed? And again, here the order doesn't matter. So the same 3 people on the team, it doesn't matter which order they were chosen in. So this is also a combination. We have 42 students to choose from, and we're choosing teams of 3. Okay, so to begin with, let's figure out how many permutations there are of 42 students, chosen 3 at a time. So 42 choices for the first student in the group, 41 choices for the second, and 40 choices for the third. And now the different ways to reorder those 3 people would be 3 times 2 times 1. Okay, in the numerator, we get 68,880, and in the denominator, we get 6. And when we divide these, we get 11,480. Okay. There are 2 try it yourself problems at the bottom of this page. So go ahead and pause the video, work through those 2 problems. When you're ready to check your answers, press play. Okay, for this first one, you should have gotten 3. And then for the second one, should have gotten 658,008. Okay, so now let's move on to section 1310, which is probability of compound events. So a compound event consists of two or more simple events, and we define simple events in lesson 13.6. In independent events, the outcome of one event does not influence the outcome of a second event. So an example there would be if two spinners are spun, or if two dice are rolled. What you get on one has no effect on what you get on the other one. Also, anything where something is drawn out of a bag or out of a deck of cards or anything like that, and then put back in before drawing another one, the the contents of the bag or the deck of cards doesn't change for the second thing that's drawn because the first one was put back. If the outcome of one event affects the outcome of a second event, the events are called dependent events. So an example here would be something where a card is drawn and then without replacing it, another card is drawn. Or the same thing with like a bag of marbles or something like that. If one is taken out and then another one is taken out without the first one being replaced, then those are dependent events because the first outcome affects the probability of the second outcome. You have a different makeup involved. So, and we'll see examples of these. But the easiest way to kind of keep these straight, obviously, if it's something like dice or spinners, something where they clearly have no connection, they would be independent. But when you're talking about things where it might be a little less clear, independent events are things that are done with replacement. Whereas dependent events are things that happen without replacement. Okay. And then to find the probability of two independent events, we just multiply the probability of the first event by the probability of the second event. So to find the probability that A and B both happen, we multiply the probability of A times the probability of B. If two events A and B are dependent, then the probability of the events occurring is the product of the probability of A and the probability of B after A occurs. So this probability here is not as straightforward to find. You have to consider that A has already happened before you calculate this probability. So let's go ahead and look at some examples. Example 1 says a card is drawn from a standard deck of 52 cards. The card is replaced and another is drawn. Find the probability that the first card is the 3 of hearts and the second card is the 2 of clubs. Okay, so this says that the card is replaced, which means that the deck of 52 cards that you start with for the first card that's drawn is the exact same deck of 52 cards that you start with when the second card is drawn. So those two would be independent events. The results of the first card have nothing to do with the results of the second card. So again, this is two events that are done with replacement. So all we need to do to find that probability is to multiply the two probabilities. So let's see, the probability that the first card is the 3 of hearts. Well, in a deck of cards, there is only a single 3 of hearts. So 1 out of a total deck of 52. And then the second card is the 2 of clubs. Well, again, we're given number and suit, and there's only one card that's a 2 of clubs out of 52 total. So we'll multiply those two probabilities, and we get 1 over 2,704. And you can leave this answer like this. We do not need to change that to a decimal or to a percent or anything like that. Example number 2 says a prize bag contains 4 whistles, 3 yo-yos, and 9 pencils. Each winner of a game randomly selects and keeps one of the prizes. What is the probability that a whistle is chosen from the bag followed by a yo-yo? Okay, so we don't specifically see any sort of word that says replaced or anything like that, like in the first one. But we are told that each winner of a game randomly selects and keeps one of the prizes, which means the prize isn't put back after it's selected, which means we have something that's done without replacement. And that would be an example, without replacement, of something, two events that are dependent. Whatever happens in the first event affects what happens in the second one. So when we find the probability, we'll find the probability of A, but then we multiply by the probability of B following A. So the first event is that a whistle is chosen from the bag. Well, we look at the contents of the bag. We see that there's 4 whistles. So 4 out of how many items total here? Well, if we add 4 plus 3 plus 9, we should get a total of 16 items. So the probability that a whistle is chosen, there's 4 whistles out of 16 items total. And now we multiply that by the probability of drawing a yo-yo after a whistle has been chosen. So since a whistle would have been chosen first, it doesn't affect the number of yo-yos in the bag. There are still 3 yo-yos. But we started with 16 items and 1 was taken out. So now we only have 15. Okay, so when we multiply these two probabilities, it will give us the probability that those two events both happen. So in the numerator, 4 times 3 is 12. In the denominator, 16 times 15 is 240. And when we reduce that, this is equal to 1 over 20. Okay, there are 2 try-it-yourself problems at the bottom of the page, so go ahead and pause the video, work through those 2 problems, and when you're ready to check your answer, press play. Okay, the first one, you should have gotten 6 over 35. And for the last one, 1/9. Okay, now let's talk about mutually exclusive events. If 2 events cannot happen at the same time, they are said to be mutually exclusive events. If you roll 2 6-sided number cubes, you cannot roll both a sum of 7 and doubles at the same time. The probability of mutually exclusive events can be found by adding. So we add the probability of the first event to the probability of the second event. So the probability of A plus the probability of B. Okay, so let's take a look at the first example. It says the spinner at the right is spun. What is the probability that the spinner will stop on 7 or an even number? Well, if we look at the spinner, and we look at what we're trying to get, 7 or an even number, and these clearly are mutually exclusive because 7 is not an even number. So what we'll do is add the probabilities. So let's find the probability first of spinning a 7. Well, there's only one section that's a 7 out of 8 sections total. So one section out of 8. And because these are mutually exclusive, we will add the probability that the spinner will stop on an even number. Well, if we look at our numbers, we have 2, 4, 6, and 8 that are even. So 4 out of 8 total. And we know how to add fractions, especially when they have the same denominator. 1 plus 4 is 5, so this is 5/8. Okay, number 4 says a 6-sided number cube is rolled. What is the probability of rolling a multiple of 3 or the number 5? Okay, so we have 6 sides, and we want to find the probability of rolling a multiple of 3 or the number of 5. And since 5 is not a multiple of 3, these are mutually exclusive. They cannot both happen at the same time. So first, the probability of rolling a multiple of 3. Well, on a 6-sided number cube, the multiples of 3 would be just 3 and 6. So there are 2 of them total out of it's 6-sided, so 6 numbers total. And then we want to add the probability of the other event since it's mutually exclusive, the number 5. Well, there's one side on a 6-sided number cube that has a 5 on it, and since that's 6 sides, it's 1 out of 6. And again, we add, they have the same denominator, we add the numerators. 2 plus 1 is 3. So 3 out of 6, which reduces to 1/2. Okay, and again, there are 2 try-it-yourself problems at the bottom of the page. Go ahead and pause the video, work through those problems, and press play when you are ready to continue. Okay, for the first one, probability should be 5 over 52. And for the last one, for part A, the probability is 5/8. And for B, the probability is also 5/8.